Welcome to problem number 36 from the June 2016 Algebra Regents exam. In this question we've got two different graphs, or two different functions, g of x and f of x. And the interesting thing is that f of x has two possible equations based on the x value. And the question is, how many values of x satisfy the equation f of x equals g of x, meaning how many times do these two graphs intersect each other? Explain your answer using evidence from your graphs. So essentially what we need to do is graph both of these functions and find out where and how many times they intersect each other. Alright, now I have to zoom in for this one. Alright, so first one is g of x equals half of x plus 1. Oh, and yeah, okay, that's everywhere. Alright, so our first one is half of x plus 1 to get our y value. So for example, if x was 0, our y value would be 1. If x was 2, our y value would be 2 as well. Well, in fact, we can graph this by knowing that the slope is 1/2 with a y-intercept of positive 1. So essentially, we're going to rise 1 and move 2 to the right each time. That might be a faster way of graphing this. Kind of like that. Maybe I'll just connect these with a line to make it a little bit smoother. Oh, hang on. Can I move that? There we go. That looks better. Alright, now the other function was 2x plus 1 when x is less than or equal to negative 1, and then 2 minus x squared when x is greater than negative 1. So what I'm going to do is draw the vertical line at where x is equal to negative 1, because that's going to be where this graph changes. And I'm going to do a dotted line for that. So along this line is where it's going to change. So now when f of x, or when it's less than or equal to negative 1, our equation is 2x plus 1. So 2x plus 1. Okay. So for example, if when x is negative 1, we would do 2 times negative 1, which is negative 2 plus 1. And that would get us a y value of negative 1. So we've got this point here. And for this one, this has a slope of positive 2, meaning a rise of 2 and a run of 1. So moving to the left, that would be our next value, and then here, and then here. And you could also find these points just by plugging in the different x values. Alright, let's connect these together. I'll just draw it freehand. Okay, now at negative 1, it's going to change to becoming 2 minus x squared on the right-hand side. Let's change colors for that. 2 minus x squared. Now if x is negative 1, let's see what happens. So it'd be 2 minus negative 1 squared, which is 3. No, 2 minus 1, sorry, that's just 1. So negative 1, 1. And I'm actually going to draw an open circle here, and that's because this function doesn't include that in the solution set, because you can see that it is greater than right here. X is greater than negative 1, not equal to. Equal to is here, and that's why I did a closed circle on that blue line there. Now, let's continue on with graphing this one. So 2 minus, if x is 0, 2 minus 0 squared is, oh, sorry about that. 2 minus 0 squared is still 2. So 0, 2 is the next point. If x is 1, you get a y value of 1. When x is 2, you should get a y value of negative 2. When x is 3, you should get a y value of 7. So negative 7, sorry. 2, 4, negative 7. Okay, so we can see this is forming a parabola here. It's going to look something like this. Oh, and by the way, you should be adding arrows to the ends of these guys. Okay. Now that we've graphed this, we can answer the question, how many values of x satisfy the equation f of x equals g of x? And again, as I mentioned before, that's how many times they intersect each other. And if you look closely, you can see that that actually only occurs once, right here. It almost happens a second time, but only once. So the answer to our question is simply 1 value of x, because the graphs intersect only once. Okay, so I hope that was helpful. That's it for this video. Thanks for visiting JD's Regions Preparation.